one of the projects we're working on at the Lugar Center is the use of abandoned coal mines for pump storage hydro. We don't have the mountains that are available out west to have two different reservoirs, but we do have subterranean void spaces from places that have been left to their own devices for decades that we could turn into the lower reservoir and then pump water uphill when we've got excess solar in the middle of the day or wind generally at night, and then let that drop down and use that as a load shift to be able to give a more steady, higher reliability electricity across the board. Well, the US is the current leader in pump storage hydro. This was developed in the 50s and 60s and 70s, especially for nuclear power plants. With a nuclear plant, the big issue is when do you have to shut it down? It's really challenging because all the welds and all the pieces and parts, they like to hum along at the same temperature all the time. So you want to have them giving a steady output. But of course, that's not what people do. They vary over the course of the day. So by pairing a nuclear power plant with pump storage hydro, then you've got something that's dispatchable and it levels out the load and allows that power plant to run smoothly for a long time. So the United States has built that up, especially over the 70s and 80s. But for the last 20 years, there's been few or no large pump storage hydro installations in the US, mostly because of pushback from citizens and environmental groups, because you're really destroying a lot of native habitats by creating these reservoirs. So that's one of the benefits of using underground mine voids, because it's generally land that's low value, that people aren't farming, they're not making state parks on top of coal mines. So it's a really beautiful solution that can dramatically shrink the time frame for installing these. And that's critical because time is money. And that's a big factor in how long it takes to get energy storage installed.